Hi, let's now look at the midpoint method and talk a little bit about why that might be preferable to the price point method, especially when we're talking about large changes over large amounts of prices and quantities. Let's use an example where we go from $2 to $4 as our base example, and then we'll switch it and go from $4 to $2. So we're going to start saying that we start with 2 and we move to 4. If we take our normal elasticity method and we calculate a percentage change in quantity from 80 to 60, which means we have a 25% increase in our quantity. Right? So 25% of 80 is 20. We're decreasing it by 20 units. So we have a 25% decrease in our quantity. The price, on the other hand, is actually going to increase. It's doubling from $2 to $4. So we have a 100% increase in price. Our elasticity is negative 0.4, which is okay. That's an elastic value. We're in the elastic region, as you saw from a previous video. But what happens if we switch this? What happens to our answer if we start with $4 and we move down to 2? What if a firm is considering decreasing their price from $4 to $2? Well, we still have the same formula, percentage change in quantity over the percentage change in price. That hasn't changed. But notice now that we're going from 60 units to 80 units. So we have a 33% increase in our quantity, and our price has decreased by 50%. As a result, we now have an elasticity that's negative 2/3. So depending on which one's our starting unit, whether we start at 2 and go to 4, or whether we go from 4 down to 2, we actually get two different answers in terms of our elasticities. This is where the midpoint method comes in and is pretty nice when we're talking about elasticity over a range. What we're really interested in is what's the elasticity over this range from 2 to 3, not necessarily elasticity at a certain point. So the midpoint method at first looks very confusing, but once you start to learn the pieces of it, it's actually not too bad. So what the midpoint method is trying to find is, it's interested in the change of two quantities. Right, so that's actually similar in terms of delta Q. That hasn't changed. But what we're doing at the bottom is we're actually taking an average over the two quantities, because we're interested in, right, over the range. So it's essentially taking that 3. I'm also interested in the price. I'm just going to put P bar to make it a little easier, because I just noticed I ran out of room. P bar just means average. So we're doing the same thing here. Instead, down at the bottom, we're doing P2 plus P1 over 2. So we have a change in Q over Q bar divided by the change in P over P bar. And what that says is it doesn't matter which direction we're going. Right? So we'll talk our way through it and we'll calculate what the midpoint method would say. Notice that we're interested in the change of Q2 and Q1. Well, let's look at our change here. Our change is 20 units. We're going from 80 units to 60 units. It doesn't matter if we start from either direction, we still get a change of 20 units. We're curious about the average Q, right? So before, the quantity differed in terms of how much we had, but between 80 and 60, we want an average of 70. Right? So it doesn't matter if we go 60 to 80 or 80 to 60, the average is still 70. We see a similar issue in price. The change in the price is $2. Right? And again, it doesn't matter if you go 4 to 2 or 2 to 4, because we're interested in the absolute value of that. We don't care about the negative sign. The average price is going to be 3. Again, we have two fractions, so what we can do is we can take this, flip the second and multiply. So what we get is 30 over 70. Remember, we're interested in the magnitude not necessarily the sign, because this is a price elasticity. The sign is always negative. So what we find with using the midpoint method is that over that range, we get an elasticity of 3/7. What you'll notice is 3/7 is right between 1/4 and 2/3. The idea here is if you were calculating a price point elasticity or a normal elasticity, your starting value matters. It depends on whether you're going from 2 to 4 or from 4 to 2. The midpoint method is saying, okay, well, what if we don't know where we're starting, or we're interested in what's the elasticity over that range? Again, we're below 5, and earlier we identified 5 as our unit elastic point. So we know that this should be an inelastic region, which is what we find. We find that if there's an inelastic region, the price change is larger than the quantity change. So this is how you calculate the midpoint method, and this is how you use the midpoint method. But understanding why we want to use the midpoint method is important when we're looking over a range of values rather than a particular point. So let's now move on to how elasticity and revenue are related.